Hello and welcome to the new session of our OpenCV course. In the coming sessions, we will deal with image transformation. So the first image transformation is called as translation. The translation is basically, it's not an OpenCV term actually, it's a term which you use in normal drawing, in engineering based drawing, CAD, things like that, where an image will be shifted to another location without making any other changes to image. For example, this is an object, it's being shifted, the location, the coordinates of this image is being shifted to another point without any other change. So that's called as a translation. We can even shift the image up, shift it down, left or right. Or we can combine these movements together and move it across the plane. And in OpenCV, we can achieve this image translation with a simple lines of code. OpenCV provides few method, mainly a method called wrap_affine, which actually shift the image. So let's see how we can use that. And before we proceed, we have to define a translation matrix, which is actually a floating point array. Here in this line, we are defining a translation matrix. It's nothing but the x and y points along which the translation should be done. And the translation matrix will take the values 1, 0, then tx. This is the first translation matrix. The translation matrix will have two rows. The first row will have the changed x value and the second row will have the changed y value. So the first row will have the values 1, 0, then tx, which is the number of pixels we need to shift the image in x-axis, that is to left or right. And if it's a positive value, then it will shift the image to right, and if it's a negative value, it will shift the image to left. And in the second row, we have the same similar matrix which takes the ty value, which is the number of pixels we need to shift the image up or down. So negative values of this digit will shift the image up and positive values will shift the image down. And then in the next line we will be calling the function called wrap_affine, which is basically provided by the OpenCV. And wrap_affine will include arguments. The first argument is our image, the image that we fetch from the user using a command line argument as a path. Then the matrix, the translation matrix. Then we will have the width and the height of the image. So here I am dynamically getting the width and height, based on the image property itself. So image.shape of 1 will fetch the width of the image and image.shape of 0 will fetch the height of the image. And once we provide everything, all these details into the wrap_affine function, it will return the translated image, and we are showing the translated image in the window. So this is the basic working of our code. And since translation is only one of the image transformations, we will be dealing with rotation, we will be dealing with flipping. So there are many kind of transformations. So in order to use all these transformations, we can easily create a common file so that we don't have to write that much of code, repeating code inside our main file. We can keep everything, the common used code, in a common file, and whenever we require, we just import it. That's all. So this is a basic form of our common file. This is completely user-defined file. We are going to write this file. And going line by line, we are importing numpy with alias np, then we are importing OpenCV, then we are defining a function called translate. And this function will take the arguments. This is a user-defined function, we are going to define it. So this translate function will take the argument. The first argument is the image, second argument is the x coordinates to shift and y coordinate to shift. So x coordinates to translate and y coordinate to translate. Then we are defining the translation matrix inside the function itself, numpy.float32. So this is a floating point matrix, OpenCV actually requires a floating point translation matrix in order to process this function. So we are defining it as np.float32. So we are using the float32 function of numpy, and we are passing the argument. The first argument is the x value, that is we got inside this function as an argument, and the y value we got into this function as an argument. And then we perform the wrap-affine function and shift the image, and we will return the shifted image. So the whole thing will be saved as a separate file so that we can include it in any number of files as required. So here is an example how we do that. This is our main file. We got all the import functions, numpy, argument parts, then image utilities. Then we are importing our imutils. So this is our imutils file that is defined by ourselves. So we are including that, and we are importing the OpenCV. These lines you are already familiar with. We are getting the argument, the image path as an argument from the user, command line argument from the user. Then we are reading the image and having it in the image object, and then we are just showing the original image. Now we are using the translate function. This is a translate function that we have already defined in the imutils file. Since we are importing imutils, we can use it directly here. imutils.translate. The first argument that we expect is the image. Yes, we are providing the image. The second argument is the x coordinate. Okay, we are providing it as 0. And next argument we are expecting is the y coordinate. We are providing it as 100. So we are just trying to shift down the image. So we are keeping x as 0 and y as 100. And we are showing the shifted down image, then implementing the wait key also. So enough with the theory learning. Let's go and do the program in our virtual machine.